industries use pipelining to produce items, so that the production line is divided into several steps, and each step, all the steps take approximately the same time, and when after a while all the items being produced move to the next step. For instance, adding a door or something else into a car. Okay, the idea with this can be used in computers as well, and we will see how soon. First, recall, to execute an instruction, the first thing we do is to fetch it from memory, and then we decode it and fetch operands. Then execute it, I mean perform, for instance, an add. And if necessary, we can write the data to memory. Or, but after, if we don't do that, we can update the register. Okay? And the idea is that instead of doing one instruction at a time, we can have 5 instructions in a pipeline working at the same time. So ideally, that would be a 5 times faster machine. This idea was introduced in the 1960s by a small competitor to IBM. The expression was that IBM and the 7 dwarfs. There were 7 small niche companies which competed against IBM, which was totally dominating. But Burroughs was one of them, as was mentioned before, and Controlled Data Corporation was another. They made the first pipeline load store architecture. Load store architecture means the arithmetic operations must use operands in a register. So you first have to load it and then compute something and store data back to memory. Okay, and what they realized was that a simpler or cleaner architecture is easier to pipeline. IBM tried to pipeline the IBM 360, but it turned out to be very, very difficult, at least if binary compatibility should be preserved. Okay, this type of simpler and nicer machines have come back. For instance, Apple have recently announced that they are switching away from Intel x86 to their own ARM chips, and ARM is an example of this concept of RISC machine. It was researched, it was used by CDC in 1960s, and then it fell out of fashion, and it came back in the 1980s with research from IBM, Stanford University and Berkeley. Okay, during the 60s it was more expensive, I mean hardware was more expensive than software, and then during the 70s software became more expensive. Okay, and the idea, one idea, which in fact was quite nonsense, was that current computers are bad because there is a semantic gap which makes it more difficult to translate high-level languages to machine code. So instead of using the RISC with simple machines, there was a trend to make more complicated computers. For instance, one instruction which can do polynomial evaluation. This may sound not too difficult to implement, but when parts of this polynomial does not fit memory and you have to do various things in the operating system, things get messy quickly. Okay, and Another reason for making complex instructions was it can reduce the code size. Since with complex instruction, the instruction performs more, so you don't need so many instructions. RISC machines typically have a larger so-called footprint. They need more memory since the operands are explicit and there are register operands in each instruction. Okay, but it was not the only reason. It was a sales feature to have complex instructions. Okay, there is a famous engineer and author of the book The Little Prince, Antoine de Saint-Exupéry. This is very, very important. An engineer knows that he is ready not when there is nothing more to add, but when there is nothing more to take away. That helps a lot to make nice designs. Okay. Researchers at IBM, under the leadership of John Koch, who won a Turing Award for creating the RISC machines, they concluded that this is not a good way to produce future machines. So, but binary compatibility is important for customers. But what they did at IBM Research was to start from scratch, and they could break all binary compatibility and create a completely new instruction set. And what they essentially did was to make a new RISC machine. So to add a new instruction, it was calculated how much will this slow down the clock frequency of the machine and how often is this instruction used. And it resulted in a very fast machine with the same semiconductor technology as was used for CISC machines. Then this the RISC was far superior. Okay, and as I mentioned at the previous lecture about hardware, Intel tried to get rid of the x86, and well, it didn't work out. I will not repeat that, but if you want to, you can check it out from the previous. So everyone agrees that RISC basically is better.